if you've got a few minutes, I'm going to take you through my 8 steps for adding fractions. This is so simple. It's the easiest method for doing fractions. When you're watching it, you might be thinking, oh, I don't want to do that. That's too much work. But if you learn how to do it and stick with it and practice it, this works on all fractions all the time. Whether we're looking at numbers, or whether we're looking at algebra, rational expressions, or calculus, this one method works on all fractions all the time. Get your PhD in math. Okay, it's very simple. The first thing we're going to do is, it's 8 steps. I'm going to write the denominators off to the side. So 14, 28, and 20. Step 2, we factor the denominators. So 14 is 2 times 7. 28 is going to break down into 2 times 2 times 7. 20, of course, is 2 times 10. And 10 breaks down into 2 times 5. Now, step 3, we rewrite the fractions using the factored denominators. So instead of 3 over 14, it's going to be 3 over 2 times 7. 5 over 28 becomes 5 over 2 times 2 times 7. And 3 over 20 is 3 over 2 times 2 times 5. Step 4, we draw a long line under the fractions. Now, if you think about it, this is 8 steps. We've just done 4 of them, so we're halfway done. The next thing we want to do is build our least common denominator. Now, this typically is where most people hate fractions, that finding the least common denominator. These fractions have decent looking denominators. It's going to be a huge least common denominator. But it's not all that hard. I'm going to show a method that's not any harder than anything you would have learned on Sesame Street. Now, if you remember on Sesame Street, they used to have this kind of a song, a little game thing, where they'd have this box and they'd say, 3 of these things are just like the other. 1 of these things is not the same. And you'd be a little kid looking at it going, the cat is not the same. Well, if you're smart enough to tell that the cat is not the same as the other geometric shapes, then you're smart enough to do this next step. Now, first thing we're going to do is look at that first denominator. We're looking at one denominator at a time. We can't just get her done. We have to do a methodical approach to this. So we look at the first one. It says I need a 2 and a 7 below the line. If it's not down there, I have to put it down there. So I'm going to put a 2 and a 7 below the line. Next, I look at the next denominator. It says I need 2 2s and a 7. Well, there's already a 2 and a 7, so I'd kind of do that Sesame Street thing, and then I'm looking at it saying kind of the opposite. Some of this stuff is already down there. Some of it's not. Well, you can see that there's a 2 here, and there's a 7 here. The only thing missing is that other 2. So if it's not down there, I'm going to put it down there. I go to the last fraction. It says I need 2 2s and a 5. Well, there's 2 2s, but I'm missing the 5. So I need to put the 5 down there. Now that's my least common denominator. That was the hard part, finding that least common denominator. I mean, if I could see that 14 is 2 times 7, 28 is 2 times 2 times 7, and 20 is 2 times 2 times 5, then I know my least common denominator's got to have a 2 and a 7. It needs another 2 and a 5. If I multiply this stuff together, 2 times 7 is 14, 2 times 5 is 10, 10 times 14 is 140. Now, it's nice to know that it's going to be 140, but I can continue to do math with it looking like this. Okay, now, the next step is we want to find the new numerators that are associated with each fraction. Well, if I'm looking at 3/14, I want to figure out what the numerator of 3/14 would be if it had a denominator of 140. Well, normally we'd be thinking, what do I multiply 3/14 by to get 140? That is, something times 14 is 140. And I could solve this by taking 140 and dividing it by 14. But that's the same as the prime factorization of 140, which I know is 2 times 2 times 5 times 7. And then, of course, 14 is 2 times 7. And if I just simply cancel, what's left, the 2 times 5 is 10. So if I were to multiply this by 10 over 10, 10 times 14 is 140, and 10 times 3 is 30. So let's go back to our fractions. And I'm going to make a copy of the 2, 2, 5, 7 above each of the fractions. Now I'm doing this because I want to find all 3 numerators that are associated with each fraction. So on the first one, I'm going to cancel the 2's and the 7's. And what's left is 2 times 5, which is 10, times 3 is 30. On the next fraction, the 2's are going to cancel, the 7's going to cancel, the 5 times 5 is 25. On the last one, both 2's cancel, and the 5 cancels, and the 7 that was left times 3 gives me 21. Now, think about this. I just found the least common denominator, not doing anything harder than I would have learned on Sesame Street. And then I was able to just cancel and multiply rather than doing some kind of division or trying to figure out something in my head. And I was able to figure out the 3 new numerators. Well, the last step, just simplify. That is, add and simplify. So I'm going to add the 30s, 25, and 21 to get 76 over 140. Now, I probably didn't even need to get the 140, because when I was looking at 76, it ends an even number. And I know that this 76 is divisible by 2, and I knew that 140 was divisible by 2. So if I was going to simplify it, I could have just said, well, whatever's in the numerator would have to cancel with something in the denominator. So let's take the 76 off to the side, and let's do a little factor tree on it. 2 times 38, which is 2 times 19. And so if I write that 2 times 2 times 19 up there, we see that the 2's cancel, and I'm left with 19 over 35. And that's my fractions, and that's the answer. Doesn't get any easier than that. Fractions are one of the scariest subjects in math. I'm about to show you 8 simple steps for adding fractions. This method can be used on all fractions, all the time, no matter what class you're in. And it's so simple. I think all textbooks should be teaching it this way. Step 1. Write the denominators off to the side. Step 2. Factor the denominators. Step 3. Rewrite the fractions using factored denominators. Step 4. Draw a long line under the fractions. Step 5. This is the only one that takes a little bit of thinking. Build the least common denominator by methodically looking at one denominator at a time, asking yourself if any of the factors in the denominator you are looking at are below the line. If they're not, you must put them there. Step 6. Make a copy of the LCD above each fraction from Step 3. Step 7. Cancel all factors above each fraction with factors in the denominators and multiply the numerators by the factors that are left. Put the products on top of the line. Step 8. Add and simplify. This 8 steps can be used on all fractions all the time.